our country, in Eritrea, we have a huge land for agricultural purpose, but from this huge land we use a little of it for the cultivation. There can be many problems, but the main problem is due to a delay to introduce the modern technology. So we decide to develop these modern technologies, as you see, for increasing the cultivation areas and also for increasing the production and equalizing also the demand and supply of in our country.
My name is Ykealo Micheal. I'm Temesgen, Department of Agricultural Engineering from Hamelmalo Agricultural College, and here is my friend, is my senior in my department, and me and my friend we decided to develop indigenously this technology as a start to overcome the problem that he already discussed. And the technology, as you can see, this one is the drone, this one is the robot, and another one is the chrome monitoring unit, which is placed in our demonstration field. The main aim of this drone is to take aerial photography, which can help people in monitoring activity in the field and crop conditions. Taking into consideration this, and we select the hexacopter drone. The components of the drone are this whole is the frame of the drone, and this one is the propeller, this one is the brushless motor, and this one is the ACS of the drone. And inside of this frame there is the battery, and this one is the flight controller, and this is the radio receiver, and this one is the radio transmitter. The propeller is 10 inch diameter and 4.5 in pitch, and the motor is 1000 kV, which is brushless, and the ACS is 30 ampere, and it is Yonus, and the battery that we use is LiPo battery, and the flight controller is KK 2.5, and the radio transmitter and receiver that we use in this drone is FS-CT 6P. As discussed earlier, using these parts, we are going to develop the hexacopter drone. In the frame, we have two types of plates, the lower plate and the upper plate. This is the upper plate and this is the lower plate. The lower plate is having the power distribution board. It distributes power to each motor independently, as you can see. This is the battery input. When we come to the upper plate, as you can see, at the top portion the flight control is fixed. In the reverse of that, the power is placed in this. This is the electronic speed controller that we are going to use for developing that drone, and it is PL 30 ampere auto. And the problem with this ACS is it doesn't give the 5 volt power to the flight controller, so we use another ACS that can give 5 volt. So that ACS can distribute the 5 volt to each of the ACS. The motor that we use in this drone is Yonus MT 22 to 900 kV. This is the flight controller that we use in this development of this drone, and it is KK 2.1.5. The first step is to solder in the ACS. As you can see, it is already soldered. The next step is calibration of individually the ACS. The first one is C1, normal setup procedure, and the second one is C2, throttle range setting procedure. The first procedure, normal setup procedure, the first thing you have to do is first you have to make this throttle down, and then on this transmitter we need to connect the motor with the ACS, and the yellow one is the signal, and this black and red are the negative and positive. We can connect it either. If you want to change the direction, we can change both of them. After connecting the ACS with the motor, we need to connect the ACS with the radio receiver in channel 3. After that, the power supply is connected to the terminal. After hearing this tune, we unlock this one, and you can see. The second procedure is the throttle range setting procedure, and in this calibration
First, we have to place the throttle at the top, and then we connect the battery. After hearing the two beep, within 2 seconds, we need to move the throttle to the down or to the bottom. This procedure you have to do for all the ACS individually.
We have developed two robots. The first one is the two-wheel drive, and the second one is four-wheel drive. And the two-wheel drive, it takes power from the battery only. And the second one, the four-wheel drive, it takes power from the battery, but it also recharged by the solar panel. When we come to the two-wheel drive robot, we have the temperature sensor, humidity sensor, and the soil moisture sensor, and also the live video show. So when we come to the live video show, we have a Raspberry Pi, which is useful for that, for transmitting the video to our laptop or desktop, which is wirelessly. It means wirelessly. If it is wirelessly, so we have to use this router. So in our laptop which is connected this controller, which have its Arduino and the Zigbee Bluetooth transmitter. So for the three sensors, temperature sensor, humidity sensor, and soil moisture sensor, in our robot we have these sensors. So the data are transmitted wirelessly through this Zigbee Bluetooth transmitter. So while it is transmitting, then the Bluetooth transmitter, also the Zigbee, which is called, will transmit the data to the Arduino, and the Arduino in the controller, it will process it, and it will display into our console or into our laptop. And also for the video show, as I told you, the Raspberry Pi also processes the actions which have received by the webcam. Then it will transmit also through this router to our laptop or desktop or mobile through Wi-Fi, it means. And also, if you want to control the direction of the movement of the robot, we can command into our laptop through by giving letters or some commands. Then these commands will transmit through this Zigbee Bluetooth transmitter to our robot. Then the robot can change its direction as we want, as we like, it means.
The operation of the two-wheel drive robot is shown in this section, and the movement of the robot, the camera, and the soil moisture sensor is controlled by the commands of the operator through a computer.
live transmission of video for spraying and weeding. The live video transmission is done by using the Raspberry Pi and the router, and the Arduino microcontroller used for controlling of this robot. Especially this weeding part and the spraying part is controlled by the Arduino microcontroller. The live video transmission of the robot is controlled using the Raspberry Pi and the router, and the movement of the robot, the movement of this weeding unit and the spraying is controlled using the Arduino microcontroller.
Here is the farm weather monitoring unit, and we see the fabrication of this weather monitoring unit. And at the outside we see the display, which is called LCD. We see the sensors.
As you can see, this one is the DH11, that this sensor measures the ambient temperature and the humidity. And this one is the LDR, that measures the solar radiation, and this extend wire goes to the ground. At the end, it has the Dallas that measure the soil temperature. This is the Arduino that's used in this monitoring unit, and this is the distribution board for the power. This one is the variable resistor that controls the brightness or the intensity, the contrast of the LCD, and this is the wires coming from the sensors to the board and to the Arduino. These wires are coming from this board and from the Arduino and from the power distribution board to the LCD.